Today you're going to learn about calculating percent composition. So percent composition is basically just asking how much of one thing makes up the whole thing. So in the example of looking at percent composition in chemistry, we're looking at how much of a mass of a substance is one element or one part. So we do this mostly either for molecular or ionic compounds, or in some cases you might see it as calculating the percent composition of water of a hydrate. So luckily you do not have to memorize this equation. So you can find it on page 12. If you go to percent composition, paste it right there. So ultimately, percent composition is looking at the percentage of composition of mass, the part divided by the whole times 100. Because again, percentages, you have to multiply things by 100. So we found this on table T. Okay. So let's use this example and see if we can solve for this. So what is the percent of mass of sodium in the compound NaCl? So my math, I like to give you the equation. So percentage equals mass of the part divided by the whole times 100. Okay. So in this case, we want to know the percentage of sodium. So percentage of sodium. So the part would be the Na. So Na has a mass of roughly about 23 grams. The gram formula mass of the whole compound is 58. Remember your order of operations here. So you're going to have 0.4 times 100, and that's going to be 40%. Okay. You can also check your answer because you should look at the actual moles. So you can write NaCl and you can figure out, okay, well, Na is roughly about 23, Cl is roughly about 35. So yeah, it's almost about a 40% split. So make sure you're always checking your answers with the real world. Okay. You're going to do some practice with this in your skill packet. So remember, go to your skill packet. And I believe it's skill 3, but don't quote me on that one. Now let's take a look at how this works for hydrates. A good point that was brought up is what is that dot all about? That dot is not a multiplication sign. So what it means ultimately is that you would have a substance, say copper sulfate, which is ionic, and surrounding it would be 5 waters. So that's what that little dot represents, is that you have this compound surrounded by water. Okay. Now, when you're doing this, you have to be mindful of, okay, well, I'm just going to be looking for the water, but what is the gram formula mass giving me? So when you're doing this, I always like to double check and make sure that everything is accounted for. So I would recommend that you do that as well. So again, my math, percentage equals part divided by whole times 100. So they're talking about the part of water. Okay. So water is roughly 16 grams for every 1 mole. And in this example, actually that's wrong, 16 for oxygen plus 2 grams for the hydrogen are going to equal 18 grams for 1 mole of water. In this case we have 5, so we're going to multiply that. So this is going to be 5 times. Oh man, really? That's what you're going to bring up? Okay. 5 times 18. So that's going to be 90. Grams of water. Okay. So the whole in this example is the gram formula mass of 250, which does include the water. So let's do that. We have 90 grams of water divided by the whole copper sulfate and 5 waters, and that's 250 grams of, I'm just going to put all. We do the math on that, that's roughly about 0.36-ish. Multiply that by 100, and you have roughly 36% of this compound is water. Okay. And again, you want to just check your answers by looking at it. And 90 is definitely less than 250. So it doesn't look like half, so it must be less than half. So that number looks within reason. Okay. Now, mind you, when we look at hydrates, and sadly we're not able to dehydrate a hydrate at this time, if you heat it, the water will evaporate. So we can check that by looking at any difference with the starting mass versus the ending mass. If any mass changes, we know by definition, especially with a hydrate, the mass that's being lost is the mass of water. So an application question of how to do this would be the one below. And again, you're going to practice this in your skill packet. A 10-gram sample of hydrate was heated until the mass was 7.24. What is the percent of water by mass in the hydrate? So we can begin with writing our equation. So percentage equals part divided by whole times 100. So you can look at it one of two ways. This is the bigger number, so that must be the whole. And this is the smaller number, that must be the part. Okay. However, 10 grams is what you started with, and 7.24 grams is what you're left with. So as we said, if we heat something, the mass that's lost is the water. So you have to solve for that. So 10.0 grams minus 7.24 grams. Minus 7.24 leaves you 2.76 grams that were lost in the water. What was that? 2.76 grams of water. So now we have our part. 2.76 grams divided by the whole, which was our beginning mass of 10 grams. Times that by 100. So that's going to be 0.276 times 100 equals 27.6% H2O. Okay. And if you take a look at it, that's roughly about a quarter that was lost, starting with a mass of 10, and we're down about roughly 72%. Makes sense. So everything looks well. Good luck with the practice. If you have any questions, let me know.